Let's take a look at this problem. And we want to use the graph to determine each of the following. Where applicable, use interval notation. Okay, so part A is to find a domain. Domain is the x values where the graph exists. Well, as it's going down, it's slowly going left, so it'll keep slowly going left till it goes to negative infinity. As this is going up, it's slowly going to the right, so it'll keep slowly going to the right till it's going to positive infinity. So domain is negative infinity to positive infinity. B is our range, our y values where our graph exists. Well, this one goes down forever, so it's going to negative infinity, and this one's going up forever, so it's going to positive infinity in terms of our y values. So this is going from negative infinity to positive infinity. C is to find our x-intercepts. X-intercepts where it touches or crosses the x-axis. Looks like negative 5.7. Maybe 0.6. And 5.7. Excuse me. Now D is your y-intercept, where it touches or crosses the y-axis, which looks like 2. E, interval and increasing, decreasing, constant. Well, initially it's increasing. So it's increasing from negative infinity. Now it stops increasing right here, which if I went straight down would be, looks like roughly negative 3. And then it starts decreasing, starts going down. So it's decreasing, decreasing. Here's where it stops decreasing. If I went straight up, looks like 3.6 maybe. And then it starts increasing. From 3.6 on, so which is positive infinity. Remember, these are always x values we put in here, and then you always use parentheses on these. F is our relative extrema. Well, extrema is where it changes from increasing to decreasing, or vice versa. So here it's increasing, and then it changes to decreasing, so this is a relative max. And it'll be at negative 3. And if I go over here, our y part looks like 7. These are written in point form. And then it's decreasing, decreasing, and here it changes to increasing. So that's going to be a relative min. And this will occur at, what is that, about 3.6 we said. And the y value, if I go over, it looks like roughly negative 5. So that'd be the point where we have relative min. Now G says find f of 1. Now again, whatever's inside your parentheses is your x, so they're telling us x is 1. And the other side is going to be your y, so we're wondering what our y is. So we're looking for a point or points on our graph where the x is 1 and then y can be something. Well, here's x equals 1. If I went down, this would be my point, which would roughly, the y would be negative 1. So it would be 1, negative 1. And all they're wanting is the y part, which is negative 1. Then h. They say the values of x for which f of x equal negative 6. Again, whatever's inside your parentheses is your x, so x we don't know. And the other side is your y. So y is negative 6. So we're looking for a point on our graph where x is something and y is negative 6. And it actually has to be on our graph. Well, if I come down here to y is equal to negative 6, if I come straight over to here, it looks like this is the point. And if I come up, it looks like maybe negative 6.3. And all they're wanting is the x part, so x is equal to negative 6.3. And I says determine whether it's even, odd, or neither. Well, it's not even. You can't take this part of the graph, flip it across the y-axis, and have it land exactly on this. It's close to odd, except for it's not quite. It's off a little bit. So this is a neither. And those are our answers.